All right, Unit 2, Section 10, numerical summaries for skewed distributions. So the mean and standard deviation you use when you talk about symmetric data. So you use mean and standard deviation when you're talking about symmetric data. So for the mean and standard deviation, so anytime that you have symmetric data, you're going to use mean and standard deviation. But for now, we're going to look at skewed data. We're going to talk about median and IQR. So for skewed data, you're going to talk about median and IQR. So we're going to talk about that right now. So define your median. Basically, that's going to be the middle of your two numbers. So in order to find the middle, you're going to basically have to put everything in order. If you have an odd number, it's going to be the middle one of your list. Okay, so the number is going to be your median. If it's even, you're basically going to have to find the average of the two middle numbers. For that one. Oops. The two middle numbers. Okay. Okay, on this first data set, it says, suppose an office manager forms a committee to explore the best way to update a few human resource policies. The members of the committee have the following ages. So they have the ages of 32, oops, where's my arrow? Of the ages of 32, 53, 29, 64, 41, 47, and 39. I want to find the median age of the committee members. So you're going to need to write the ages in ascending order first. So ascending order basically means smallest to largest. So I'm going to have to write them in numerical order first. So 29 is going to be my smallest, then 32. And then my next one is 39, then 41, then 47, then 53, then 64. So you need to write them in numerical order first. And so since there is, let's see, so there's 1, 2, 3, 4, 5, 6, 7 numbers. It's an odd number, okay? Then there's going to be 1, 2, 3 here, 1, 2, 3 here. This is my middle number here. This is my median number. So my median number is 41. So my committee members, so the committee members are typically 41 years old. So right now, instead of you looking at the chart, before we just had to look at the chart and guess because we didn't know what each bar meant, but now we know their actual ages. So now you can basically tell me exactly what the median age is. My median age is 41. The typical age is 41 years. Okay, however, on this one, it says the manager now realizes that there are a lot of employees in the office who are recent college graduates and decides that one should be added to the committee to help with age diversity. The new committee member is 23 years old, so they're going to add a 23-year-old in the group. So I'm going to add in a 23-year-old, and so I'm going to add in a 23-year-old, and so then my other numbers again were 29, 32, a 39-year-old, a 41-year-old, 47, 53, and 64. So now there's 1, 2, 3, 4, 5, 6, 7, 8. Now you have an even number. So now if there's an even number, the middle is right here in the middle. So this is the middle. So in order to find your average or to find your median, you're going to have to average those two. So 39 plus 41 divided by 2 is going to give you your average. And that average is going to be 40. So that is your median average. And so it says, how did the new member affect the typical age of the committee? So not much. So you went from, so it didn't go up much, or I mean, it didn't go up down much. It basically went from 41 down to 40. So it didn't change it by that much. Okay, so now that we're done with our center, when we're dealing with symmetric graphs, now we're going to deal with our, oops, I need a pen. Now we're going to deal with our spread. So for your spread, so what goes with your median, okay, we're going to deal with your IQR, basically is your spread. And so your IQR is called the interquartile range. So think of quartile as like quarters, 25% range. So your median splits our data set in half. Quartile splits them in half again. So to give you quarters, 25% of our data in each quarter. So your interquartile range is quartile 3 minus quartile 1. So think of it like you're splitting your whole into 3 parts. So here's quartile 1, quartile 2, quartile 3, quartile 4. So your quartile 1, this is basically the end of quartile 1, this is the end of quartile 3. So this is the end of quartile 1, this is the end of quartile 3. So your interquartile range is this range right here. This is your interquartile range, is this area in here. This middle 50% right here. So your quartile 1 is the median half, is the median of the lower half of the first data set. So this part right here, this is your median. That's the middle of your graph. And so your quartile 1 is the middle, that's the middle 50% of this bottom half. And then your third quartile is the middle top half of this graph. So your interquartile range shows the variation for the middle 50% of your data set, and it's the distance between the first quartile and the third quartile. And it is most useful overall. This is more useful than the overall maximum minus minimum, since it's the location of the most typical data. Because most of the time you're going to find most of your data in here rather than in this area or in this area. So that's what an interquartile range is this area in here. Okay, so here was our original data set and our expanded committee. So it says rewrite the ages in ascending order for our groups. So again, let me write our groups in order. So for our original data set, that was 29, 32, 39, 41, 47, 53, 64. And then our expanded one was the same thing, but it had a 23 in it, and then 29, 32, 39, 41, 47, 53, 64. Oops, 64. Let me double check. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So again, we need to know, here was our median here. So our median was 41, and our median over here was 40. Okay. So it's important to know where those are. Now our quartile 1 in here is this number here is in the middle. Our quartile 1 is 32. That's quartile 1. And then on the original committee, and on my quartile 3 here is 53. On the second one, because you did not use a number from this group, your 39 and your 41, you averaged to find the 40. You're going to use all 4 of these numbers here to find your quartile 1. So your quartile 1 is going to be in the middle of these 2 numbers here. It's going to be the average of these 2 numbers. Your quartile 3 is going to be the average of these 2 numbers. So your quartile 1 is the average of these 2 numbers and the average of these 2 numbers. So this one's 29 plus 32 over 2, which is going to give you 30.5. So this one's 30.5. And then this one, you're 47 plus 53. Sorry, my phone went off. And that one's going to give you 50. Okay. And then let me change colors. Okay, so my interquartile range is going to be my 53 minus my 32, so that's going to be 21. My IQR here is 50 minus 30.5, so that's going to be 19.5. And so then they want to know, consider the expanded committee, so that's this one here. They want to know what percent of committee members had ages less than quartile 1. So here's my quartile 1, here's my quartile 3. So there, remember, here's your quartile 1, your quartile 3. There's 25% of your data in here, 25% in here, 25% in here, 25% in here. So there's 25% in this area. And it says B, what percent of these committee members had ages greater than quartile 1? So that would be 75%. And then C says, what percent of these committee members had ages between quartile 1 and quartile 3? That's 50%. Then it says, why does it make sense for each of these to be multiples of 25%? And that's because they were split into quarters. And a quarter is 25. And that's what basically a quarter means. Okay, so this screen is just a summary of what we did on the last screen. So it says our typical age for the original committee. So by typical age, they're basically talking about your median. So when they ask for typical age, they're talking about median. That was 41 for the original committee, and it was 40 for the expanded one. Adding a new member decreased your typical age of the committee members. The middle 50% of the original committee had ages ranging from 32 years old to 53 years old, which had an inner quartile range of 21 years old. The middle 50% of the expanded committee had ages ranging from 30.5 to 50. So this one they were looking for, to your middle 50%, they're looking for your IQR. And then that was a 19.5 year interquartile range. And so adding your new member again decreased your variation. So it didn't change it by very much. Okay. Number 6 says the graphs below show the distribution of heights for 18 male college students and their fathers. Number summaries were calculated in StatCrunch and are also provided for each data set. So they give you the mean, and they give you the median, and they give you the IQR and the standard deviation. Your mean and your standard deviation go together, and your median and your IQR, and they give you the graphs. So it's kind of hard to tell whether, looking at them, kind of if they're symmetric. This one's a little bit more obvious that this one's probably more skewed than this one is. However, the easiest way to do is to look at your table, okay? If you look at your table, even though this says 69.2 and this says 70, how you can tell is if your mean and your median are not the same, then you would want to basically use, it's a skewed graph. So the only way that this graph is typically symmetric is if your mean and your median are almost exactly the same. So since your mean, so if your mean is different than your median, then your graph is skewed. Oops. You're going to use median and IQR. So it says which number summaries are appropriate to use. That would be your median for your standard deviation and your IQR for your variation, because both have a skewed graph. Now, the ones for the sun is a little bit closer. You can see the 69 is a little closer to the 70. So this is a little more symmetric. It's almost symmetric. Whereas this one's 67.5 and 68.5. This one's a little more skewed. However, they're still not exactly the same. So this is more skewed than anything. So it says record the numbers you will use for the center. So we are basically going to use your median and IQR information. We're not going to use those. So we're going to use 70 inches for the son, and we're going to use 68.5 for the dad. It says, write a sentence comparing the typical heights of the sons and the dads. Use problem 5 as a guide. So the son was typically 70 inches tall, whereas dad was typically 68.5 inches tall. Okay, record the numbers that you use to describe the variation. So if you look up at the chart, the son was 3 inches and the dad was 5. So I'm going to type on this because I'm not going to have a whole lot of room. So it says, write a sentence comparing the variation in heights for the son and dad using these numbers. It said the dad's, let me see if I can get it to type. Maybe not. Try again. Oops, that's a little small. Let me try bigger font. Let's try black font. Okay. Okay, so sorry, I'm trying to get it to type because otherwise, come on, type. Aren't you going to type for me? Okay. I'm trying to get it to type. Come on, baby. Maybe not. Let's try this again. Okay. The dads had more variation in height than the sons. I'll move this out in a second, so just be patient. The middle 50% of the dad's height were spread out over a 5-inch range. Oops, can't spell. While the middle 50% were spread out over while the sons' heights were spread out over a 3-inch range. Okay, let me spread this out so you can read it. And I can't spell range. Let's see if I can get in here and fix the spelling on ranges. Yeah, I can. Okay. So then it says, note if the graph is symmetric and the other one is skewed, it's customary to use the median and IQR to compare the graphs. So this is important. So let me find a highlighter color that's better than this. So if we give you two things to compare, all of this, we give you two things to compare. Oh, that's a really bad highlighter. Okay. If we give you two things to compare and one of them is symmetric and one of them is skewed, you need to use median and IQR for your, okay, let me undo that one. You need to use your median and IQR for your graphs. Okay, it says wages and salaries. Wages Wages and salaries are data sets that are often skewed due to small number of people who earn higher amounts compared to those who earn less. Suppose the hourly wages at retail store chains have a median of $18 and an IQR of 20. The annual salaries at corporate headquarters for retailers have a median of 45,000 and an IQR of 8,000. So you're trying to compare hourly wages and yearly wages. So it says, so you've got to think of it in this way. It says, for which group might there be a lot of variation? Which group might there not be a variation? So your hourly wages have a lot of variation, since your range for the $20 for the middle 50% has a big spread for the hourly wages, whereas the range for that $8,000, or that range of $8,000 for that middle 50% of the annual salaries is not variation, because they're much higher salaries to begin with. So let me type that down. Let's start here. Come on, typing. Oops, I don't want it pink. Nope, don't do that. Okay, black, type. No, I need typing. Typing. No, I need typing. Okay. Let's undo this, undo this, undo this, undo this. Let's make this smaller. Okay, I want to do this. Frustrates me trying to do the typing on here. I can't find the thing down here to move it out. Sorry this is taking so long. It takes forever to put a box on here, and I can't move it. I want to stretch it out and then move it so I can type in it. Sometimes it's not as easy. Okay, I might just have to write it with a pencil. Okay, so I'm just gonna have to write it. So I can't get the typing thing to work well. This typing thing is gonna annoy me because I can't stretch this thing out way down here. The typing thing is going to annoy me. Okay, I'm gonna put it up here. I'm gonna type the. And then give me a second, I'm going to move. See if I can move this whole thing. Oh, here we go. Okay, now I can type. Okay, so the hourly wage, sorry it's taking so long. Wages have a lot of variation, since a range of $20 for the middle 50% is a big spread for hourly wages. Whereas a range of $8,000 for the middle 50% for higher wages is not much variation, since the wages are higher to begin with. Okay. Okay. Sorry.